side of me. I will skip a couple which we can start class with, and then make sure if there's any questions you have that you star the problem, and we will go over it at the start of class the following day. Okay, so chapter 3. In 3.1, we will be solving linear systems by graphing. So let's start by talking about a system of equations. A system of equations is when you have more than one equation. An example here is you have your f of x equation and your g of x equation. A quick reminder, the solutions are the points on the graph. That is the solutions for both of these equations. So let's look at when we are given a point or an ordered pair, and we need to check if it's a solution of each of our equations. So our first example here is the ordered pair 5, 1, a solution to f of x. So let's substitute in both of these values. So if we have f of x, we have f, our new x value is 5, equals negative x, which turns into negative 5, plus 6. Okay, go ahead and solve. And we need to make sure that our result in the end for f of 5 would be 1, because that is our y value. So we have f of 5 equals negative 5 plus 6, which finally gives you f of 5 equals 1, which, yes, that is equal to 1. So the ordered pair 5 and 1 is a solution to f of x. Let's check g of x. So we have g of 5 equals 3/4 times x, which is 5, minus 1. Okay, that will give us g of 5 equals, let's see, we have 5 over 1, so that'd be 5 times 3, which is 15 over 4. And in order to subtract our fractions, let's turn 1 into a fraction with 4 in the denominator, which is just 4 over 4. Finally, that gives us g of 5 equals 11/4, which is not equal to 1. So the output of this equation is not 1. So no, it is not a solution of g of x. Okay? So let's do this for one more set of ordered pairs, and then we will leave the other one for class. So we have f of negative 8 equals negative 8 plus 6. Okay, we can simplify that as negative times negative gives you positive. 8 plus 6 gives you 14, which is not equal to 1. So no, negative 8 comma negative 7 is not a solution to f of x. Let's try g of x. G of negative 8 equals, substitute in negative 8. Okay, g of negative 8, let's see, negative 8 times 3 gives you negative 24, divided by 4 would give you negative 6 minus 1, which finally gets you negative 7, which is our output. So yes, negative 8, negative 7 is a solution to g of x. It's a good reminder that you will have multiple points that are solutions of each of your equations, because, like we talked about before, the solutions are just the points on the graph. So if we have a line, which each of these are linear equations, you will have multiple points landing on that line. Let's leave 5 and 6 to open up class with the next day. So if we were to graph f of x and g of x, what would we notice about their solutions? Okay, so let's start by graphing f of x. So f of x is negative x plus 6. So let's start with our y-intercept. 1, 2, 3, 4, 5, 6. Plot a point right there. Then we have a slope of -1. So we can write in a couple of points. And then draw in our line. All right, there is f of x. We can label it quick. Okay, let's do the same for g of x. So g of x is 3/4 x minus 1. So our y-intercept is -1. And rise over run. 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Right there. So let's plot both of our lines here. And it will give you something that looks like that. Okay? So with both of these lines, we have, functions that continue in both the negative and positive directions forever. So f of x and g of x have infinite number of solutions, when they are separate. Although, when you would say we would need to find a solution of both of these lines. Well, if you're finding a solution of both of these lines, there's really only one point that would be a solution, which is where they intersect or both of the equations are true. So the second portion of this is when together they have one solution at the point of intersection. Which in this case is 1, 2, 3, 4, and 2. Okay? And this is essentially what we are working on when solving a system of equations. We are trying to find what is that point at which they intersect each other. So just below this, we have our instructions for how to solve a system of equations graphically. We'll learn how to solve them in other ways in the following days. So we have to first graph each equation separately, which is what we did above. We know that the solution is the intersection of the lines. So it's the only common point between both graphs. Okay, finally, let's check our solution by substituting into the original functions. All right. So that is how we will solve a system graphically. Okay. So let's take a look at the second page here. We are going to solve two of these, and we will leave the other two for the start of class. Okay? So, like we talked about, there are many different ways that we can graph a linear equation. Although, I think most of us prefer to graph them in slope-intercept form. So, let's solve our second equation here, already in slope-intercept form. But let's solve our first equation to be in the same form. So let's start by subtracting 2x from both sides, which will leave us with 3y equals negative 2x plus 18. Go ahead and solve for y. So we will divide out our negative 3 coefficient, which leaves us with y equals negative 2 over negative 3. We can just make that 2/3. X 18 minus 3 gives us negative 6. So now, right here, we have our linear equation. So let's go ahead and graph it. So our y-intercept is negative 6. 3, 4, 5, 6. And our slope is 2/3. So rise 2, run 3. Rise 2, run 3. It is very important when making these graphs that you are accurate, as if you are not, it may be difficult to find the point of intersection. Let's go ahead and graph our second equation here. We have our slope, or our y-intercept of 8, 2, 3, 4, 5, 6, 7, 8, and a slope of -4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1, and so on and so forth. So let's go ahead and graph our line. Kind of missed here, but we get the point. So as we can see, we have our point of intersection, which would be right here at the point 1, 2, 3, and 1, 2, 3, 4, a -4. So this ordered pair would be the solution to our system of equations. Okay, so pretty straightforward. Let's skip number 2. We will do that one in class, but give it a try on your own first. I expect that you guys have all of them complete when you come, and we just kind of check your answers and work through them together. Okay, for number 3, let's do the same thing here. Let's solve our top equation for slope-intercept form. So let's subtract 4x from both sides. That gives us 6y equals -4x plus 18. Divide our coefficient 6, which gives us y equals -4/6, which we can simplify as 2/3 x plus 3. Okay, so let's go ahead and graph. Some of you may realize where this is already going. Let's go down 2 over 3. We can go the other direction too, up 2 over 3. And graph our line. All right, so let's go ahead and graph our second equation. We have a y-intercept of 2, down 2 over 3, up 2 over 3. And you guys can probably already see this one. You will notice that if you graph it accurately, and maybe more accurately than I did it, that both of these lines are parallel to each other. So this is one of those special cases. When you have two parallel lines, you will have no solutions to your system of equations. Oops. Okay? No solutions. The other thing that you will notice, in some examples, you will have two lines that overlap each other or have the same equation. In that case, you would have infinite solutions. Okay, but we will look at an example of that in class. Quick summary here. When they intersect at one point, you have one solution. Like I said, when they overlap, the lines coincide. So you will have infinite mini solutions. And then finally, when they are parallel, you will have no solutions. Thanks for watching. Make sure you come to class with any questions.